Check 1 2 1 2. Check 1 2. Okay, check 1 2 1 2. So we're looking at a switch mode power supply here. We'll flip this on, and the very first thing I'm going to do, there's 6 pins out. I believe there's 2 separate voltages outputting. At least that's my thought. Is I think it could be plus minus. I really don't know too much about this power supply at all. We need to figure out all of the what it's supposed to be outputting, and why it's not outputting anything. I mean, it's not outputting any voltage at all. It's making some relay clicks, but nothing steady or current. So very first thing I'm going to do is check some of the obvious things here. And make sure that we've got fuse continuity, which I'm sure we do. Perfect. Okay. Checking this fuse out. It looks like we come in here, we go through the fuse, we've got a neutral come into this relay, so the very first thing that we hit is this relay. Let's see if that's the case. See if that's the case here. So with our power off, I'm gonna check continuity. So from this fuse through the fuse, we hit input neutral, which also hits this relay here. We go through the fuse. We hit several things here. What are these things that we're hitting? So it looks like we hit the outside, go through, come into the center. Let's turn, just trying to get a basic idea and understanding as to what we're looking at, the workflow of this. Any one of these components at this point could be bad. Haven't really ruled out anything. So we come in through here, we hit, it looks like we hit this relay, possibly. Yeah, it looks like this here is the relay. curious as to if there's only 2 pins on this or not. Looks like we also hit this coil here. Yeah, let's see if I can get you a better angle here. It looks like we also hit this coil here. Then it looks like we hit a regulator here, a voltage regulator. Looks like we've got our down in here. Looks like we have our rectifying diodes. This, let's see. This is possibly acting as some kind of optocoupler. Let's try and understand this better. So I'm going to look up, if you give me just a moment. Let's see what is this component value. LTV702, LTV702, LTV702. Of course, it's pretty hard to find information on. This thing has kind of been an online mystery with lots of mysterious components, and not too many people have any information on anything surrounding it. Let's see, maybe I can find a data sheet here. LT702. Directly. Yep, it's an optocoupler. Okay. That makes sense. Pretty basic, generic optocoupler. Good to know. Okay. Excuse me. So that's going to be on our feedback path. Let's see if we get some kind of rectification on these diodes here. Let's start there. So I've turned our mains input voltage on. Let's see if I probe this diode here. I'm getting 60 volts DC. 60 volts DC. 60 volts DC. Making some very interesting noises here, so if you give me a second, I'm going to listen quite closely. You know what? These noises are so interesting. I've got an idea. I want to listen to it closely. I'm going to go get my stethoscope, and we're going to take a listen to what's making these sounds. So give me just one moment. I'm going to go get this tool. Okay, I'm back, and what I'm going to do is check this out. All right, let's take a listen to what is making these sounds. Okay, so based on what I'm hearing so far, it appears to me like this this may be a thermistor. Let's see if I can get this shot here. This thermistor is our clicking culprit. Unfortunately, it's heat shrinked and covered, and I can't really tell what it is. We might have some rectifying diodes here, but it looks like it was kind of hidden behind this cap from my point of view. I can't really see it, but behind this is a bridge rectifier. So I'm going to, in its casing, I'm going to go ahead and probe that and see what information we have. So we've got a minus, positive input, and that's 150 volts DC stable. It seems to be maintaining 150 volts pretty well. So let's take this take a closer look at this component here. It would be great if I could take the heat shrink off, but I don't know if I'm going to be able to. I could probe it though. We should have an input voltage and an output voltage, theoretically speaking. Check 1 2, check 1 2. Okay, great. Just checking audio levels briefly. Okay. So if I maintain a probe on the outside of this rectifier here, we have negative over on this side, and then this thermistor here hiding right behind it, or beside it. If I turn this over, I can find where that component is. And it appears to be, let's read resistance across. 20K. Just one moment. Okay. So I will attempt to probe this ground here. Let me turn it back on. Looks like we have our rectifier ground here and our thermistor here. What are we reading voltage wise? 150. Wow, that is not stable at all. 150 to 210. Moving back and forth. Even though the input is a steady 154 volts DC. We're getting all kinds of wild, crazy voltage ranges out of this thermistor. Interesting. Okay. So, I think it's worth checking this component out. So where is the output of, I assume, this bridge rectifier? I'd like to take a look at this. The output of this bridge rectifier. Excellent. Okay. So here's the rectifier. Here's the output, positive output. Okay. And we go in through this thermistor. We go out to the other side. Currently, right now, I'm just checking to see if this other side of the thermistor is coupled to ground in any kind of way. What is going on with is this thermistor then going very interesting. So we're going back, we're going out of this rectifier in through this side of the thermistor, out of that side of the thermistor to possibly this transistor. Let's see. No leg of this transistor has continuity to it. Possibly these diodes that are right here. Yes, both of these diodes. And then we go out of these diodes into possibly the base of this voltage regulator here. So I'm starting to just kind of build concepts of what this circuit is looking like. So far I'm seeing we've got the rectifier here going out into through this thermistor here, which is going through these diodes into the base of this transistor. If I turn it on and probe voltage, the base of this is seeing fairly, oh, I'm just guessing it's the base, but the center pin of this voltage regulator here, this power transistor, is seeing steady voltage, which is looking okay. $54, $200. Just some very interesting behavior, spiking up and down from 150 or so to 210 or so volts. Interesting behavior on this side. So let's try and understand just real quick what this transistor here is that's heat sinked to here. Let me see if I can get it at an angle where I can read the component. Fortunately, I might have to bend this bracket back. Let's see if I can get some tweezers in here and work it out. I can find my tweezers, that is. That's alright. I have another option. How about this here? I'm just going to get this blade into, hopefully, this bend. It's just slightly too thick. I need something even thinner than that. Are you kidding me? Let's see. Wow, what a... So I need to basically pop it out. It's pushing in, wrapping around the back side of this here, and pushing in like this. If I pop out one side, I'm trying to be very careful to not put too much strain on the soldering of this transistor here, though, so it's not good for me to pry too hard against it. That's the issue. Assuming I can do that. Let's see, how about maybe some forceps connected to it? How about that? This tool always comes to my rescue. There we go. That should be fun to try and figure out how to get back in. Now we've got a clear view of what this transistor is. And it is a don't be scratched. Let me get something to clean off this face here. TF10N60. Allow me to look that up. My memory's so bad I already forgot what I said. TF 10 and 60. 10 and 60. One 0 and 60 MOSFET. Here's the data sheet for it. Perfect. Power MOSFET. Pin 1 is all the way to the left, this way, and pin 1 is gate. And then we have pin 3 is source and pin 2 is drain. So, let me write this down so we don't forget. If you're looking at the pins like this, then this camera might be a little overexposed. I'll hold it up to the camera. Then pin 1 let me just check my pen out and make sure that we're correct. We are gate, drain, source. Yep. Gate, drain, and source. And that will look like gate, drain, and source. Okay. Helpful. So, now what I can do is it's going to be backwards now. So from the bottom of the board, it's going to be source, drain, gate. I've got to write it down, or it just helps to organize my mind in that way. So what we're actually doing is we're taking this input voltage and we are, here, let me turn power on. Going through this thermistor, through the diodes, into drain. So that actually might be, let's see, where's our gate? Our gate is over on this side. Our gate has no voltage, 0.7, very unstable voltage. Okay. Interesting. I'm getting curious if this power transistor might be an issue for us. We have just a moment. So what's interesting to me right now is if I turn this over here. Okay. This seems to be making some kind of effect right here. Touching this makes an effect on the noise that it's making. Interesting way. What component do we have here? Also, this isn't always 100% of a sign of an issue with a component, but this component has a very faded and almost kind of, doesn't feel hot, but it has a faded and almost just worn down looking face to it. The lettering is worn off on it, and that can sometimes be a sign that this has been overheated or something along those lines. So what's interesting is the center pin of this has been cut off. I'm taking a look here to see what this component doesn't look very good on its face. DSNK4. Wow, what a bad looking component. Let's see. This component looks like it's been through some war or something. It's DSNK4. Jeez. Let me look that up and go from there. DSNK4. D5NK4. MOSFET. Yep, from ST Electronics, that's correct. Okay, I found the exact component. And this component here is DSN, or not S5, I said D5NK4, and its pinout is going to look like this. If you're looking at the component in its package that looks like this, and then it's got a short little leg, and then it's got its bigger leg. If you're looking at it in that way, it's going to be 3, 2, and 1. Or in this way, it's going to be this is going to be 1, 2, 3. Which one is going to be gate? Drain, source, drain, gate. Okay. So this is interesting. I'm going to test the let me untangle this. I've got this all tangled up here. Okay, much better, much better. I'm going to take a look at the pen. This one's pull this way. Let's see if doing this will help it. A little. I think it won't fall now. So let's test this diode that's right in front of it on this board. Put my diode reads good. .5. Interesting. This little board here is quite the interesting problem here. Let me turn our power back on. I'm going to listen one more time. Try and read some voltages off this. .015, 123, negative 0.7. So our center pin here, drain is getting 123, while our gate is getting nothing and source is getting nothing. Nothing practically. Never mind, minus 1 volt DC roughly, and then 123. An unsteady roughly 15 volts off this transistor here. So let's try and understand where this board is, what it's doing and its position that it's in. So it looks like we come out of the optocoupler. So where's our initial volts? So I understand what it looks like to me is we come through this circuitry here, loop back it, obviously. We feed back through the optocoupler, which is here, and then that goes back into this board here, which is doing some kind of switching back through our main power transistor, and that kind of feeds back through some components. That's what I understand so far. That's what I understand so far. Just because I see some, and this is no indication, or nothing's for sure that a component is bad because of this, but I am seeing some slight discoloration in this part of the circuitry right here where there's 3 voltage regulators or switching transistors of some kind. I'm going to check those in diode mode just real quick. Hold up a second, guys. I think we might have some shorted transistors here. Sorry, my cough is so bad. This one seems to be reading okay. But what is going on with this guy here? Check this out. I'm going to put it in continuity mode so you can possibly hear that beep. I mean, just shorted right the way through. Okay, before we move any further, let's take a look at this transistor. Let's pull it out of its spot here. This one is going to be an interesting one to pull out. So it's this here, which from the front kind of looks like this, how it's clipped on. I might actually get this camera a little closer. I think I would like to do that. Bear with me while I'm going to switch to my other camera while I'm adjusting this one. I think that's better. So it's going to be interesting trying to pull this out. We'll go with this method again. Seems like the same concept, just vertically instead of horizontally clipped. Wow, it's clipped all the way down though. Oh man. Man, oh man. And then it's glued on the other side. That's the big issue. See if I can pull back some of this glue here. Yes. See if I can pull out some of this glue here. That's going to be a big issue. I don't want to bend, so these aren't meant for prying too hard. I don't want to bend them, so I'll use another tool instead. Oh, I doubt these will get a hold. Yeah, maybe they will. They sure do make this difficult to get a hold of, though, don't they? It should slide directly up out of this, based on what I'm seeing. I don't know why it's not. Might have to, there we go. Clip directly down. It took a little force. I didn't even bend this too badly. Nothing that can't be fixed. Okay, now we should somewhat easily be able to just pull this transistor out here. Now my desoldering gun should be nice and warmed up. So here's what I'll do. I clip on to one side here. Just give some slight prying pressure, nothing crazy. And the other side here, always remember to clean your gun out before and after. Clean that tip of the desoldering gun. Make sure that the hole is nice and clear. Okay. Now continue the slight prying pressure from one side while I'm desoldering from the other. This is likely to possibly give me a hard time. Normally they do. And sometimes it's worth taking some solder again. And just flowing new solder over the hole. Okay, and then you try desoldering once again. It should be a little easier. And that mostly did it. Yep, there we go. So, and then remember to clean after. Excellent. And then we can power off. Okay. So, desolder a bit. Take some, if you can get some leverage on the other side by pulling with something from the other side, that's great. That's it's a slight pull, slight wiggle, but not too much of either, or you're going to wind up damaging the pad that it's soldered onto. Slight pull, slight wiggle, slight pull from one side. The other side, desolder. If you're having some trouble because your desoldering gun isn't wanting to desolder completely, reflow with some new solder and then try again. And you might even have to do that 2-3 times maybe. But with some patience, it's going to come out. So now what we can do is pull out the transistor tester and see what it has to say about this guy. It's showing diode, which might possibly be correct. How about testing it backwards in there? Just get all the data we can from it. And it's showing diode again. And this actually appears to be just 2 diodes. A 2 diode package in this here. Now, where I desoldered the pad from though, let's see. This pad is still shorted on both sides. Why is this pad shorted? Trying to make it make sense here. Okay, let me think about this briefly now. Why are we shorted across these? Here we're not. Here we are. I mean, just short it all the way around. I mean, it would make sense that these are shorter, possibly. Let's try powering it on. See what we get. Very interesting. The problems intensify. You know what, guys? I think that this might take a little thought. I'm going to think through what we've learned so far. The circuitry that we've been through so far, understanding kind of the flow of this, which, you know, all switch mode power supplies of this type are fairly similar, but not exactly. And or they at least all share some characteristics. So it's going to be interesting. I'm going to think through this, what we've discovered so far, maybe try and see if I can find any more information as to what's going on with this circuitry, and then I'll come back and we'll talk about it some more.